think we're running right on time. It's 4:55, right? Everybody here? How's everybody's day going today? Is everybody having a fun day today? Yeah. Last talk of the day. I think this is the last slot before we all get to go to happy hour. Everybody's got a happy hour dinner tonight. It's New Orleans. It'll be fun. I'm Eric Uythoven. I'm the CTO and co-founder of PEGRight. We are a systems integration consulting firm. I've been studying the space of adaptive authentication for a couple years, getting into user entity behavior analytics. Today's speech, you probably have heard about the Alliance, the companies that are in there, probably heard what they do. I'm going to talk briefly about that and then get into user behavior analytics. Most people have seen a slide like this. I really like this one. Information is beautiful. It's kept up to date. It shows you all the breaches that are out there. It's kind of my source to see who's getting hacked, how much it's been hacked. But the reality is the proof's in the pudding. It's happening out there. People are getting attacked all the time. As of over the last 3 years, 1.3 billion records have been compromised. And it just keeps going. Now, the defenses against this are to have better authentication policies, and then if they are getting in, how fast can you detect it? So look at the trend. What's the latest trend? It's really about stolen credentials is the latest trend. People are stealing identities, or they're getting sold, or it could just be somebody on the inside with a financial objective or gain, disgruntled, whatever it may be, that they want to move laterally throughout the network and not be detected. So they've gotten through, they've authenticated, and now they're using the network, and they want to be able to steal information. So they stage the information. If you look at what Verizon's been talking about, 2 out of 3 of the report or incidents are really about stolen credential, somebody on the inside, however they got it. Dell Security Works is saying the same thing. So what does that tell us? We're all people. No matter how well-intentioned we are, there's always loopholes. So I think about, the Trojan horse. Let it ride into the walls of Troy. Wow, meltdown happened. Or maybe it's the, Great Wall of China. People got through there just by bribing the gatekeepers. So it does happen. I mean, no matter how well-intentioned we are with our systems, there's always got to be a failsafe that some people are getting through. So a scenario, think about it. Employees targeted with a specific spear phishing email. They respond to it, give some information. At that point, it's stolen, and everything that you've put in your walls to stop it have now been penetrated with a credential. Somebody's in the network, and they're moving throughout it. So the whole premise of behavior analytics is to see the differences in how that's being done and be able to trap the person. I always think about passwords. They're really hard to get rid of. We love them. I've been at this conference for going on 7 years. And every year, I sit in at least one talk that is, passwords are dead, they're never coming back. But yet, I've done a lot of consulting jobs in the last year, and every one of them has our friendly password. So it's going beyond that. What are we going to do? And so we have to realize that's going to be really, really hard to get rid of, but we need better ways in order to detect threats happening to the system. So I think about history. Started with the corporate firewall. Where are we today? We're really on authentication policy. It's about risk factors. So we've heard about context-based risk. We've heard about identity profiling, and we're hearing about maybe blacklisting. So if you can monitor blacklists and correlate those names that have been, say, off of Ashley Madison against your corporate employees, it's known that they use kind of the same password patterns. And so just knowing that information can make your network more secure. And when you have those risk signals that are high rated for your users, you want to be able to step them up. Where we're going tomorrow is you hear, anybody go to RSA this year, to the big security? How many of you saw identity analytics was like the buzzword of the conference? And it's really hard to know what that means. So I'm just going to give some introductory material in a few minutes about that. But going with today, what's the conference talking about? Managed devices. The use case I come across a lot, Office 365, I want to know that the device being used is one that the corporation or whoever is doing business manages it. So that technology is available today. Talk about device profiling. It's about a fingerprint of the device. So if you're going through a web browser, you can sniff the device. You put in a hidden image on it, and it starts profiling, because the hidden image between the served entity that's serving it up and the user's browser creates a connection that you can get the user agent information, get the network it's off, you get the time of day, you get the application. All of that can then be used to build a profile. If that profile is different going forward, then you can signal them for step-up authentication. Identity profiling, still fairly new in my opinion as to how that's being done, and it's usually about geovelocity, geofencing, very simple use cases in and around how an identity is using it, or maybe the time of day applications are being used, application ordering. Very simple analytics are coming out, but it's available today, and there's companies and products on the market today doing that. The key is that it's not just about a username and password, it's about bringing all these factors together. And lastly is blacklist, which was I was saying before. That's more focused on if an identity is known to have been compromised, whatever website it's at, users tend to use their password multiple places. So wouldn't it be great to have a service where you can hit a well-known large list of blacklisted emails after the person's authenticated and check, are they on the list, and do I want to do something about that? Do I want to step them up, or more importantly, you can actually have them change the password. So I think about SAML-based architectures, and I think about access gateways. The today is really in SAML-based. You authenticate, it's a one-time event. It happens, you've granted access, and then every time coming back through, it's going to be a new application to reevaluate that. Access gateways are really a reverse proxy, so traffic is constantly flowing across it. What you can really do with that is you can get more of a continuous authentication experience. Continuous really focusing on, I can continue doing device profiling. I can see devices moving networks. I can see patterns of how that happens. I can do better at my identity profiling, because since it's constantly happening and you're reevaluating all the time, you can see how the identity is being used more on the network than if it were a one-time event. SAML architectures, we're all probably doing some form of that, being a federation conference hosted by Ping Identity. We're all familiar with their product. When you move into the access gateways, it's a constant enforcement point. And really, it starts setting the stage for user behavior analytics, which is you can continue capturing information about how that user is using the system, not only from your access gateway, but it can be from multiple data sources that you have in the system. So what I'm saying today is password and authentication policy, that's where we're at today. It's a commodity. Use case, you go to your bank, you log in with a new browser, pops up and says, hey, you need to go through some more friction. I'm going to send you a text message or a code, and you have to prove who you are. It's going to go to your email address. We live in that world today. We are also doing some identity profiling. But really, where do we want to go? We want to go towards more security analytics, and it's really figuring out that puzzle. There's a lot of products that are out there today that are emerging, and it's still really a new frontier. Two use cases. When you're on the inside of the network, so let's suppose that somebody did break into it. What are the things you're worried about? You're worried about somebody getting in and moving laterally to figure out where your information is. They're using a real identity. They've gotten through the defenses, and now they're looking for information. They haven't done anything yet, but they're looking. The other one would be misuse. Somebody disgruntled on the inside that knows where the information is, and what both of these use cases end in, exfiltration of information. Whether it be PCI, PHI, whether it be corporate proprietary information or corporate confidential information. That's the worry of what the insider use case is all about, and it's developing advanced techniques to even detect that, which gets us into user behavior. So there's really 5 steps you can think about in this. You have to collect it. You have to collect a lot of information, and the real hard part of this, it's a lot of data. It's a big data problem. The second is the learning. It rolls off the tongue real easy to say it's machine learning, advanced algorithms, and man, everything's sold for you. Everything will work. Very difficult problem. The exploration is really exploring the data in an automated way. It's very hard to crunch the amount of data that's out there, so you need to have a technique that really knows how to risk score aggregate the information, make it intelligible, so you can anticipate what to do. Once you've anticipated and you've identified where the risky behaviors are of your users, you can actually go and perform some negation, negating what they're doing. So let's talk about the collection. Really, it's about more data sources, better results. And the real hard part is the streaming data. I was recently on a cruise, sat down next to a lady, didn't know she was with the DoD. She started talking about, gee, this big streaming data thing. How do we deal with streaming data? And there are frameworks out that allow you to do with it, but it's so much information. How do you stream it through, process it, actually perform the algorithms, and then bring it back together to be intelligible? So really, that's the challenge. How many of you are familiar with Hadoop as a framework? Has anybody used Hadoop? So this is a very Hadoop-like thing. You stream in the information, you distribute it. So at that point, you're really not so worried about how the analytics are working. You're distributing the load, and the more information you have, you distribute it across multiple things. Microservices really tend to fit this model real well, which is a self-contained app server and a very focused processing element. So as you map the data into your distributed data, you reduce it through the microservices to get out useful information. So it's about the 3 Vs. Gartner talked about the 3 Vs all the way back like 2001, 2002, when they were really thinking about big data. And it took almost a decade for really that to come together in the Hadoop framework, and some of the big data frameworks are now available to the masses. It's about volume, velocity, and variety. So the volume is how much you can push through it. The velocity is how do you scale it. And the variety is how many different sources you can handle. And so that framework has really figured out how to do it, and you can apply it to the networks today. And this is starting to really come out. And a lot of different interesting products in this market space are actually doing this today. So now that I've got it, I have a learning framework. Went to RSA, talked to about 20 different vendors. And there's 2 buckets that really came out that were interesting. One bucket was more about rule-based modeling. It's really statistical analysis. So it's a first-generation analytics, very popular. And really what they were about was known patterns. So if you think about the old SIM systems, they called it a digital signature. Risk scoring was really based on something you knew, and you could calculate a statistical probability between what you know and an outlier. Very straightforward. Problem with the approach, it's a 0-day attack. You can't catch them that way. You have to know the pattern. So machine learning and adaptive analytics has really started to come to the foray. It's been in the financial industry for a while, some of the bigger banks, but now it's becoming a little more available to the masses, and it'll become a commodity probably in 2 years' time. Really, it's about how do I predict what's happening? So when you think about it, it's taking historical information, and then it calculates the probability. What's the user going to do next? So as opposed to being based on what they've already done and saying is an outlier, this is saying, well, they've done these last 5 events in sequence. We kind of know what the 6th one's going to be. So when the 6th event comes in, you measure it against, is the event one that I thought it should be? So it's predicting where the user's going to go next, and then you risk score off of that as your primary key. And so the algorithms continue to crunch what are they doing in the past to predict what should the user being done in the future. If you can put both of these together, you have a really, really good analytical system. So why is this hard? It's about data cleansing and normalization. We know what to do, but to get to true machine learning, the data sets are varied, and so you have to normalize that. That gets us into the learning. So again, you saw the framework. You take the raw data sources. You come through the distributed connectors. All microservice driven. That's your mapping phase, and then reduction is all about cleaning, normalizing, and coming out with an event type. Because those event types are going to feed your models. You can have one event type feed multiple models. So again, how much data can I collect, and how can I run it through the models? So cleansing, it's all about removing noise, getting the outliers thrown out where you know they're not relevant to the story, although outliers can be the story. So, you got to be real careful in the modeling phase and how you actually do the data cleansing piece. Standard event structures, and I'll go to that in a second. And then the model actually consumes it and then gives you the answer. So it's all about answers and modeling, and just it's a flow. So you can imagine this massively parallelized system crunching all these numbers. Normalization, it's really taking the raw event and parsing out the fields that you want to pay attention to. Cleaning, it's about removing erroneous values, and in some cases, mathematics needs to have a discrete number for the model to work. So you might bucketize things based on the type of data. You might have to fill in missing values with defaults. So you see in the example here, very simple, Joe Blogs or UDemo, how to take that, normalize it, and then prepare it for a model. So the key here is that you have to have an event structure that you can process in the model in a consistent manner based on all the different data types. Machine learning would take those and put it into different types of models. So there's really 3 types that are out there. You have the classifiers, the naive Bayes models, the decision trees. You have clustering models, which the cluster relearns as you keep evaluating off the cluster, whether it be the k-means or the hierarchy model. You have classical analytics, which we talked about. You take all of these things together, and really what we're trying to do is explore the data. So exploring the data is really, how do I take the semantic web of events? And you see the web here of all the things. I've done the modeling. I've got a bunch of answers, but what does it mean? What you can do is take your distribution and standard deviation type of model. You can add that to a risk score of a decision tree model. You can bring a semantic web or an object graph. So object graph databases are really good at taking 2 different events, finding relationships between the 2 events, and then taking the answers of the 2 events, and you get a composite risk score. You're really trying to combine all these mathematical models into something that's meaningful. And so how many of us seen a product that has like a dashboard that says plus 50 ranking, plus 75 ranking, plus 100 ranking? What's happening is a buildup of numbers off of the math from the standard deviations of what is the normal behavior or the relationships of normal behavior to give you a mathematical answer that can be evaluated. So it's giving you a risk signal of how that user might be risky in the system. The whole framework comes together as a funnel. The funnel is really what it's all about. Collecting it down, thinning it down, and trying to get to something where there's an alert signal, alerting a user to do something. Negating the threat as the ultimate endpoint. Negation could be some rules engine. How do you go through a series of rules to get to an automated action or perchance a manual action? Certain things could be easy. I know that data's exfiltrating out of a particular database. I haven't seen the user or the query happen in a very long time. Just shut it down. And the computer can crunch that, catch it quickly, and shut it down. User and operations may take a while to find those types of things. So really we're talking about sophisticated software to stop exfiltration. If you think about putting this whole architecture together, it's really starting at the data source, and all the square boxes here, those are discrete things you can manage as data in your big data enterprise and be able to look at it in dashboards, drill down in the data, do something with it, actionable information. The more rounded boxes are really the steps you have to go through. So your data source is where you connect to your data. You cleanse and normalize it to get to your events. The events flow through the models to give you answers. You have to aggregate the information so that you see what the user behavior is. It's really about the user behavior and the learning where you really have your main dashboards. You need to see what they're doing, have the risk ratings, make it something you can do something interesting with, or stop attacks. Lastly, that turns into filtered information on your dashboard that'll get you to alerting, whether it's manual actions or automated. Everything there becomes policy at the point of how much do you want to thwart it. Interesting thing you can do, you can send them into a fake processing element just to continue monitoring what that user is, trace them back to the source. You can just stop it if you really want to, and just stop access. So there's a lot of work still to be done in the action modeling. The state of the industry of what I saw and am seeing today is more on the capture side. So it's about the mathematics of the machine learning, bringing together the big data, semantic web or object graph technologies, and really creating a picture of what's happening in the network. With that as just a quick intro to user behavior analytics, be more than happy to go into deeper conversations with anybody. And right now I have 5 seconds to take a question in the corner.
How do you bootstrap the system? I mean, it's great that once it's steady state, you've got lots of data and examples of good or bad behavior, but you need a corpus of data to act on. So what are the approaches?
Most of the approaches are you need at least 7 datas to start learning. So that's called model training. And in model training, let's take a Bayesian network model. You have 7 days worth of data, and you do what is called a 90-10 split. So you take 90% of the data, and 10% is your expectations. You run the 90% through, get the statistical analytics of what that is so that it has predictions of next behavior. Then you run the 10% of events through it to say, did I get bad answers out of that? You do that 10 times over, changing the 10% window so that you can see, have all my models converged on what the behavior pattern is for the user. And that's basically called model training. That's like a Bayesian network model training. Decision tree or clustering algorithms have the same type of model training, whereas the clustering is more about the mean and the standard deviation of how it's calculated. Again, you have to train the model first. You just don't plug it in and it works. And the norm is between 7 and 14 days is a good starting point. 30 days would be good because certain jobs in a corporation are performed monthly or more like bi-weekly, like payroll kind of accesses. And so you kind of got to know the types of users in the business to know how much you need. But you have to train the models. Did I answer your question? Okay. Any other questions? Sir. Okay, so correlating it to, as I said, one event type can be pulled into multiple different types of models. And then the data cleansing can be multiple different data cleansers can actually result in an event type. The hard part here is the event types and the models that go with it. So in a massively parallelized system, you may have so many different data sources, but what you need to do is think about how to cleanse the information, normalize it into a set of manageable event types, and then have a set of manageable models that in order to get the desired effect. So the parallelization, what's nice about microservices is you need to have a watchdog that's watching the network that knows where all of them are running, because it's all about server capacity. And in all of those, the real goal is to have a set of manageable event types. Did I answer your question clearly? Okay. Question? Very, very interesting. I mean, that's an interesting question, and in the back of my mind, I got this thought that's called bring your own algorithm. And so any one network that comes along, the algorithms are going to get more sophisticated. So the types of things I'm looking at from the vendors right now are that they're not advertising exactly the algorithms they are in the seeding and how they're done. You have to be able to bring in new algorithms and plug them in. And that way, the release cycle of bringing them in would be kind of thwarting where you're going. It can't be a static set of algorithms being run by a particular product. You have to be able to plug in new techniques on a consistent basis. So my thinking has been, go back to the days of antivirus. They had the weekly data file come out. And the weekly data file had like new ways of doing things or new ways to detect patterns. If a good vendor in this space is going to do a really good job, they're going to be giving out maybe monthly new algorithms that are tweaking the parameters constantly as they understand the industry and how people are attacking systems. and continually innovating so that it doesn't become static. And that's really what I'm looking for in the user behavior analytics. Is a lot of the vendors I see today, they're lined up in 3 algorithms, and they're pretty widely published. You can find it in there's open source toolkits out there built on Apache Spark, and you can predict what those are. And so yeah, the bad guys can do that. What the bad guys can't do is model the actual users and the data that's been built up on it. And so the answers should be unique enough that that's not 100% of a concern. I mean, it is a concern, but I wouldn't say that's the core concern. The core concern would be is that they've already exfiltrated enough information they can build the identity profile themselves and be able to manipulate it. That would be more what I'd worry about. Any other questions? I know I'm over time. It is this the last talk of the day? There's a keynote at 6, 5:30. Oh, wow. Is it 5:30? Yeah. Let's go see the keynote. Thank you, everybody. Have a great day. Appreciate the time.